I will be mostly helping my customers to migrate their workloads from SQL Server to Postgres, MySQL to Postgres, and I also work on NoSQL type databases, which is called DynamoDB, right? And I am also work on the PostgreSQL for the Babelfish. So today we will demonstrate a topic on the JSON and JSONB data types, how these data types are important and how these data types helps us of NoSQL kind of workloads in the RDBMS. So I will hand over to my colleague.
Hello everyone, hope I am audible to everyone. So my name is Sashikant. So I am also working on Amazon from last 6 years, and I have a overall 13 plus years of experience. And if I talk specific on Postgres, then from last 8 years I am working on Postgres. So basically I am a database consultant, and then I help customers to migrate their workload to AWS. So so today we have the topic on JSON and JSONB, and then how do you decide how to choose the right data type, right? Whether JSON or JSONB. So this is our agenda. We will be talking on the JSONB overview, and then we will slowly give you a difference on JSON and JSONB. We will tell you what is the indexing strategies with JSONB or JSON. Then the access patterns, right? When you go with a JSON or the JSONB, and then how the query looks like. Then the last is the best practices with JSON. So before jumping directly into JSON, let me just talk a little bit on the PostgreSQL, right? So the PostgreSQL we know, right, is a relational database, which means that it is ACID compliant. It is that the data is stored in form of tables, where each table has some columns, right? And then within a database we have multiple schemas, we have multiple tables, and each of those tables are they have some common columns where they are related with primary keys and foreign keys. And basically the table that we see is kind of normalized, right? The data similar set of data is put into one table, and then the data is broken in such a way that they have a relationship with other table. And let's see some of the real world use cases where we say that how Postgres is able to cope with all those real world use cases, right? So we all know that these days we have a lot of e-commerce application, or maybe if we talk about some event logging, right, or maybe analytics, and then maybe content management system. So we are all aware of these things, right? And if you just understand this, so the data coming from all these systems are not just relational, right? The data is also some kind of NoSQL data type. So let's try to understand how Postgres is able to provide the feature in such a way that these business workloads can be handled. Yeah, it is working. Yeah. So how Postgres we can use Postgres to handle these scenarios, right? So let's take one scenario, or the business use case, which is the e-commerce. So if you see in the screen, right, I have just taken a product catalog scenario. So basically when you design the database, right, or the data model within Postgres, then here I have only taken three different types of products. One is the clothing type, another is the smartwatch, another is the laptop, right? And if you see here, the table for clothing or the table for laptop, they have different set of columns. They have the number of columns also varies, right? So only the first three, type, name and price, are same, but all other columns are different. So if we have to design in a relational way, either we need to create three different tables, or maybe if we are going with a single table, then the many of the column values will be null for the type, right? For example, if I say RAM is a attribute for the laptop, right? But RAM doesn't make any sense for the clothing brand. So that's how the problem arises, right? So with that, let's see what is the downsides, right? Or the weaknesses. Maybe like, I'll say that the weaknesses with respect to the use case that I just talked about. So the weakness I would say is that one is the structural, right? Which means that it is more on a table format where the table columns has to be predefined. It cannot be a NoSQL data type where the table can the columns can change dynamically. Then the query complexity. We all know, right, when we work on a relational database, the query, right, we have to use multiple joins, we need to use subqueries or maybe some union, then the order by, group by, right, and then the query becomes complex. And then the performance also is a problem when we work on a big query, right? So if we write a query now, maybe it would run fine, but over the time we hit into the performance issues. Then obviously storage is again another thing that we are worried on writing a big query and then writing all those, like, we need to adjust the memory parameters and all those. Then the last is the indexing. So when you write a query and then if you do not have a proper indexing mechanism, then your query performance is again a problem, right? So let's see how Postgres provide all those non-relational types, right? Maybe the data types which can handle more data, right? Which can, like, not just the scalar data type, like, numeric or character, right? So maybe the record or array, HStore, XML, JSON and JSONB. So these are some of the data types which are non-relational, which means they can store like a large amount of data, not just a numeric or text, right? So our topic is more on the JSON and JSONB, and I think we all know about JSON and JSONB, or how does it look like. So let's just see, like, I just want to bring everyone into the same page just by showing how a JSON looks like, right? So the JSON is like, it's on the left side. If you say it's like, enclosed within a bracket, and all those there is a key value pair, right? And then this JSON is a just export from pgadmin. So if we have pgadmin installed in our laptop, then we are using JSON, right? So it means that, like, whether we know or we do not know, we are using JSON somehow, right? And many of the config files, if we see, like, just if you search your laptop with .json, and then you can see many of the like, JSON config files, or maybe the log files, right? And then here so the right side image, just so that some of the tools which everyone use, like the Grafana or Docker or GitHub, right? All of them have some kind of JSON in some format. So now let's see what JSON is, right? So as I said, JSON, it just stands for JavaScript Object Notation. It's very easy readable, which means that, like, you have a key and value. That means anytime you just pick a value, you will have the metadata attached to it, so that it gives you the proper meaning, right? And it is a very lightweight, and that's one of the good reason why many of the services, they use JSON for their communication. And the next is that, almost all the programming languages that they use JSON for interacting with different services. So the down image is just like, you have a 3-tier architecture where you have an application and you are doing something, and like, you are invoking some get or post methods, right? And then those messages will be in the form of JSON, and then it goes and then hit directly to a database. And then if the database is capable enough to store the data without doing any kind of transformation, then it is well and good, right? You do not need another layer just to transform the data in between. So yes, Now, when does Postgres has JSON? So JSON is added to Postgres in 9.2, and then later JSONB was added in 9.4. Both this JSON and JSONB data type are still available, and they have some differences. We will talk through them in more detail in our next slides, but just giving an overview that both JSON and JSONB accept the same type of input. Only thing is that the difference is how the data is stored underneath, right, under the database. So that's the only difference within that. If we talk about JSON, data is stored in the form of plain text. The only syntax validation happens is that whether it is a valid JSON or not. If that is not a valid JSON, then JSON will give an error. But there will be no semantic checks. The semantic checks happen on the JSONB data type. So JSONB stored in a binary format. So JSONB stands for JSONB binary, or some people refer that as better. Reason because there are some performance implications with JSON data type. So that's how JSONB came into the picture and the performance got improved. Right, so many people refer that as JSON better for JSONB. So we can see that, there were significant improvements or enhancements happen to those two data types, JSON and JSONB, over the releases with Postgres. Yeah, and as I said, JSON is the data type, right? It can be stored in the same table. You can have a column called you can have column as text, and then maybe another column with numeric and another column as JSON. So which means that the table can store both relational and then non-relational, which means that it's a multimodal feature. Right, and JSON, yeah, of course, this is a NoSQL capability that gives Postgres the more capability. Now coming to the advantages, right? As we speak, one is the schema flexibility. So if we go to the main problem or the use case that I was showing on the product catalog. So there we had a fixed table structure. Now with JSON, that fixed structure is nowhere. The structure can be defined dynamically. Then reduce time to market. So if your APIs or the services they have JSON communications, right, and if the database directly accepts the JSON format, so you can put as is, no intermediate layer to transform your data to relational and then store back to the tables. So you get the benefit of both worlds, which means the relational and then the NoSQL data feature. So wherever you need relational joins and all, you can do that, or maybe the NoSQL feature as well. And then migrate from other database is easy, of course, other databases, other commercial databases, they use JSON, and then if you want to migrate, it is also easy now. Then integration with APIs, we already spoke about that. And then the next is if you are already in PostgreSQL, right, your workload is running in PostgreSQL, and then maybe in the recent development you feel that, okay, I need a NoSQL feature, then you can consider JSON as your workload. So the enhancements, yeah, there are a lot of enhancements within that, within PostgreSQL 17 to from 9.2. But yeah, in this slide I just tried to highlight some of the major enhancements. If we see the 12 PostgreSQL 12, there is a JSON path queries addition, right? So JSON path queries means you can traverse through the JSON. You can traverse through the keys and then back to the nested keys, and then you can get the value of that. So we have examples for that. Maybe we'll cover more detail about that. PostgreSQL 13 added a date timestamp for the JSON path query. And then PostgreSQL 14, it's subscripting for the JSON is allowed, similar to the arrays. If you say that, okay, array of 2 or 3, right? So similarly with JSON also you can do that feature. For PostgreSQL 15, they are added like the log, the PostgreSQL log also you can export or you can configure that to log in JSON format. So there is a parameter log underscore destination, so you can set the value as JSON log, and then your log can be in the form of JSON, and then you can export, and then you can do any kind of analytics on that. PostgreSQL 16 added lot of JSON array handling features, lot of functions has been added to PostgreSQL 16. And then PostgreSQL 17, which is a very important feature I would say, which is JSON underscore table. So if you see that the JSON structure, it is just a key value pair, right? And then JSON 17, they said that if you want to see the in a relational way, JSON underscore table is the function where you can see the NoSQL data in the form of a table. So now let's take the use case, right? If you have some relational tables, maybe the very famous tables, if I say the departments, employees and employee address. So there are lot of columns, and then each table are related with the primary key and foreign key, right? And you do some inserts into the table for each of those tables. So how do you really design this in a NoSQL way? So see, there are different forms of NoSQL designing. This is one of the form, like the basic form I would say. But yeah, when you design your NoSQL data model, you have to first identify your access pattern. Based on the past pattern, you just go and then design the NoSQL data model, right? And here if you see the employee ID, which is the unique for each of those JSON values, and then you can have your personal infos, employee details, address, right? All those. And if I just go and expand this employee details, you can have so this department or the manager, right? If you see, those are again the nested JSON. And if you just expand this address, again you'll see that its address is an array of JSON, right? Where address you can see you can store multiple addresses. So here you can see that it stored the home address and then the work address. So when you need a query to get the employee details, you can simply just only one entity will give you all the details. So now how do you query the JSON and JSONB, right? So I'll hand over to Aswin to go over from here. Thank you. But yeah, if there is any question, you can ask now.
It's about joins.
Joins on.
Okay, so I have one JSON object,
Mm-hmm.
another table, another column, JSON.
Mm-hmm.
Another
Mm-hmm.
column, non-JSON.
So JSON has different the functions, right, where you can access each of those attributes, right? But when you do a join, basically it's not about you need a join, right? Why do you need a join, right? So if you need a join, then why not putting into the same JSON, right? So the basic question is that we just want to avoid the join in order that our query performance will be faster, right? So basically we need to do that. But yeah, if you want to do a join, you can do that.
Technically it allows.
It can be, right? Yeah. Thank you.
Yeah, just to address.
One question
Yeah.
regarding this JSON. When we are storing the data in the JSON or JSONB format, so how big document we can store means as compare our MongoDB document or some Couchbase DB. So is there any limitation for storing the data in that particular
Yeah, just
JSON?
Yeah, we have the column level hard limit. Yes, that is 1 GB. If I am not wrong, that varies from.
I think for JSON it is 1 GB, but
Right.
JSONB it is 256 MB or something. Is there?
Okay.
Okay, 1
Yeah.
GB.
Yeah. And coming back to your question, it supports for the join, but only the thing we need to use the respective operand to write the result in a text format. So we will see a lot of data type incompatibility. Let's say if you try to join a column which is of integer data type with a string, there will be implication or implicit conversion will be taking place, which may cause some, if let's say if you running such kind of queries on a larger data sets, you will see a data implication. Okay, anybody has any other question? And before we move, anybody has worked on JSON? Thank you. Okay, so here a glance of how we can just push the data for JSONB and JSON columns. So for JSON and JSONB, the only difference is like, as my colleague said, so in JSON, it will do a preliminary semantic checks, and it carry forward the white spaces as is. It's like stored as a text. When it comes to the JSONB, you can see the difference in terms of when we query the data, right? It rightly formatted and it thoroughly validated. And one more difference is like the data will get stored in binary format. So when you push the data into the column which you have defined with the data type JSON versus JSONB, there will be a performance implication for the JSONB, okay, compared to the JSON, because JSON will first parse the whatever the text that we try to push to that particular column, and then it will store in the binary format. Okay, here the one which I was explaining about, you can see out there, right? So here in JSON versus JSONB, in the right hand side is the JSONB, the left hand side of type JSON. Here it stored the data as is, and it also carry forward the white spaces, and there is no data level validation that has been done. Syntax level validation has done, but there is no data level, so the duplication is allowed. Okay, here the glance of the few operands. There are many JSON operands that are being supported, but these are the few operands that we can take a look at in this session. So contain operations. I try to put the things in a way to match with the SQL. I mean the not the NoSQL, the just the general SQL programming language that we use. So if you look at here, the operand which is with a question mark and the pipe symbol, you can relate that with the in operator. So let's say if you want to perform some operations on the JSON type data and see the multiple values or the list of values that you would like to pass in the where condition. So this is the operand that you can use, and we have other operands like a key exist, which is like a if the values that we have specified to check those, so this operand will help us. And the first one is the containment operator, which is most effectively used in the JSON, right? And coming to the indexing part for the JSONB type, if you happen to create the index on a column which is of JSONB type without specifying any path, right? So the one complication that I can call out was your index will be it will be more consume the memory. I mean to say is index size gonna increase, right? And you have to specify or create the index in this particular format, but we haven't made any we haven't given any further instruction to create what type of index it's supposed to create, right? In that case, it gonna go and it will choose the default index, which is called B-tree index, right? And if you look at the explain analyze, after you create both of these indexes, and if you just go with the explain and analyze index, and if you don't follow the typecasting, what it gonna do is it will what it does, like it will logical reads gonna go up, right? And the key point here is, if you look at here the column JSON doc, that the operand that they are using versus the operand that which is being used in the below code that I am highlighting, this returns the text, this operand means is it return the text, whereas the operand which is mentioned in the first one, right? So we are implicitly converting it to the integer just to match with the input parameter that we have been passing from the application or any of the application or any service that we are making use this SQL statement. So try to avoid this kind of conversions, right? Okay, coming to the GIN index. So we talk about B-tree index. So how B-tree index well suited for the JSON or JSONB type, right? Now we come to the GIN index. GIN index will work for which gives a very optimal performance for certain use cases. So it doesn't mean that we have to enforce and create the GIN index on a JSON and JSONB of type columns. So here, if you look at the GIN stands for generalized inverted index. It's provide an ability to search the things which is nested in nature. Like if you have the data which is being stored in nested format, like if you have a hierarchy level of kind of data that you meant to store in the JSON data type. So GIN index is the recommended index that we had to create with. We have two options with the GIN index to create. One is with the generalized index with default option. The other is GIN index with operands with path. So we will see that. And if you happen to include all the fields, let's say the default index, let me go with, yeah. Here if you go with without this option, right, what it does is like it creates a index which is equally like 80% of your base table. So it will create an index with that size, that level of size. So which means that you have been creating a very large index, which leads to maintenance complications, and you require to do the vacuum, right? So those performance implications and the long-term maintenance implications will come into the picture. Okay, these are all the operands. If you had to happen to create the GIN index, we have to consider these operands. If you happen to use these kind of operands, then go for the GIN index. Okay, now let's compare with the B tree and the GIN index. When to choose the B tree, when we gonna go with the GIN index. So let's say if you have an very not the larger data set that you are dealing with, right? If you have some limited set of data that you are maintaining, and your query patterns are like exact matching, I mean exact match operators that you would like to perform, and any range queries. The range is nothing but the between class. If you happen to use the between class, go with the B tree index of creating that, and sorting and single key lookups and any key values, right? So if you happen to query the data which not had any hierarchy level in structure or in nature, then check that and just go with this option, B tree. And B tree is certainly small when it compares to the GIN index, and B tree are considerably suits for the small tables. I mean to say, when you are maintaining the data and you meant to create some index on the JSON data type column, then you just consider for the B tree, right, on the JSON column. And if your table go for regular updates, let's say the JSON data type column goes for a regular updates, go for the B tree. If not, the other side of the GIN index, if you happen to perform the contain operators, right, GIN index is the right candidate for that, and the key existence checks. So hopefully the people who work on the JSON and JSONB, if they widely use their application level, they can understand the why these container operators and key indexes key existence checks are well performed through the GIN index. And any complex JSON queries, which means that, as my colleague said, if you have multi-level hierarchy level JSON nodes that you are maintaining in your data, then this is the right candidate. And if you happen to search any full text kind of search, if you would like to apply on this particular column, you just go with the GIN. So as I said, GIN index will come with it will be ending up, if you happen to create a GIN index on a larger type of data that you are dealing with, your index size will be grown up. And it is recommended for the occasional column updates for the large tables. And we have to keep in mind that when we consider the querying, when we perform some queries, right? So we have to concise to these query patterns. So which means that we had to thoroughly evaluate the query patterns before we make a decision whether we should choose the GIN index or not. Okay, here on a high level, the parameters that you can consider for the JSON versus JSONB. As we said, we discussed raw text, which means that it carry forward the white spaces, line feeds, right? So it is stored as raw text, and here it just convert. When we push the data into the column, it will convert into the binary format, and it will store in its tree structure. Writing is slight faster because there is no parsing, right? Very minimal parsing techniques will be applied when we choose in the JSON. When it comes to the JSONB, it is slower in nature, right? It has to parse and compress and store. Yes, white spaces and importantly duplicate keys, we discussed this, right? So in JSON it will be preserved, whereas in JSONB it will not, it will be removed. Order of the keys preserved. In JSONB you cannot alter it. Index supported, partially yes, we marked it as no, but it supports. And JSONB, anyway, we discussed the GIN index. JSON item edit, yeah, here let's say if you have an requirement where you want to achieve the JSON item to be edited, if your data is being stored in JSON format, you had to convert them, the implicit conversion that we talk about, right? So you had to convert when you query the data and make an update. Okay, best practices: only create the GIN indexes for frequently accessed queries. That too, we have to keep in mind that the index size will be large in size, and which leads to the maintenance, and regular vacuum has to be run. So GIN index is best for the search operations, as we discussed, right? So if you happen to do such kind of operations on the data that is being stored in JSONB format, just go with this option. So regular maintenance is required, right? As I said, like your index size will be 80% of your actual table, right? We have run through the scenarios where it, let's say you have 100 GB of table, right? So your index gonna be approximately 70 to 80 GB. So to maintain that, or in a longer tenure, so you have to have maintenance plans ready. And use appropriate operators. Importantly, the operators that we discussed, right? Let's say there is any key existence. So for the GIN index, we discussed, right? So these are all the operators that are recommended to use. If you happen to use other operators, it still work, but there will be a performance implications, or the database resources will be consumed, right? So we will not be using the database resources at max, right? If we wrongly use any operands. With that, here the reference links. The first one talk about the toast. So we were talking about JSON-B, right? So how data compression will takes place, what kind of compression techniques the Postgres uses, right? So those things, those details can be refer in that particular link. And I have also get a chance to.
How we can open this reference link?
Okay, those are all of them are hyperlink. Once this deck shared to you, probably you can access those links.
Okay.
Okay. I also happen to check the multilingual support, and I also check the Chinese characters. This JSON and JSONB supports for that. I also check for our native language, right? It accepts the native language, Telugu as well. Yeah. Rest of the things you can go through these reference links. That's all. I'm wrapping up. Anybody has any questions? Yeah.
Multi-schema, possible?
Multi-schema?
As in trying to store it one column, maybe one row has a particular key as a string, and the next row has the same key as an integer. Is it possible to store like that?
Yes. See, in a given table, let's say, so we create this JSONB as a one particular column with a data type JSONB. So you can still treat this table as a relational. But the column that we define has a capability of storing the details in a JSON format. So when you really push the data into that particular column, there are certain validation checks will be performed at the database level, and it confirms back to the service which is trying to load the data, stating that whether this JSON is valid or not. If that is not valid, it throw an error and it will terminate the transaction. So any performance implications that you came across, or any other insights that anybody would like to share? We love to hear you. So even some special type of characters which we wouldn't ever happen to store them in the database is supported. I have checked for the SQL, PostgreSQL 16 version, it is supported. Like the wave symbols and everything is supported. Chinese characters, multilingual text. So even I was surprised, like even in the hierarchy level also it's supported, and I was able to query it. By passing those special characters, I was able to query it. Okay, that's all. Thank you very much. Thanks for the opportunity.